A glass photographic plate still carries the moment humanity's universe became too small. On its surface, one handwritten letter is crossed out. Another replaces it. V-A-R. That tiny correction did not announce the discovery of a new object. It forced astronomers to abandon the belief that the Milky Way contained everything that existed. The star itself barely stands out from the countless specks scattered across the plate. Yet once its light was measured, the borders of the known universe could no longer stay where they were. High above Southern California, the dome of the 100-inch Hooker telescope rotated toward Andromeda during the night of October 5th into October 6th, 1923. At the time, it was the largest operating telescope in the world, powerful enough to separate individual points of light inside what many astronomers still called a spiral nebula. The accepted map seemed complete. In the prevailing model defended during the Great Debate only a few years earlier, those graceful spirals were not separate galaxies. They were nearby clouds, folded somewhere inside the Milky Way itself. That night, the telescope was not meant to rewrite the universe. It was simply pointed at a question the old map had not settled. Edwin Hubble exposed a glass photographic plate to the faint glow arriving from Andromeda. When the exposure ended, nothing dramatic appeared. The plate looked much like countless others collected at Mount Wilson Observatory, tiny black points against a pale background, each one recording light that had crossed a distance no human body could feel. One mark drew his attention. At first, he believed he was looking at a nova, a star that had suddenly flared in brightness. He wrote a single letter beside it, N. That notation fit comfortably inside the accepted picture of the universe. Novae were expected. Nothing about the observation demanded a larger cosmos. The plate survived, and so did the ink. Days turned into weeks as more photographs of the same region accumulated. Hubble did not treat each plate as an isolated image. He placed them into a blink comparator, a mechanical device that rapidly switched between photographs taken on different nights. Almost everything remained still. The surrounding stars held their positions without change. But one point of light refused to stay the same. It brightened, faded, and brightened again. The motion existed only because time had been compressed into alternating images. Without those separate plates, the change would have remained hidden in plain sight. The original label no longer fit. Hubble crossed out the letter he had written and replaced it with another notation. V-A-R. The correction remains visible today on photographic plate H335H, preserved in the Carnegie Archives. The discovery did not come from a dramatic flash of insight. It came from a careful willingness to let the evidence overturn an earlier conclusion. Recognizing a variable star answered one question and opened a larger one. How far away was it? Years before Hubble pointed the Hooker telescope toward Andromeda, Henrietta Swan Leavitt had been studying photographic records at Harvard College Observatory. Working with 25 variable stars in the small Magellanic Cloud, she found that a particular class of stars, Cepheid variables, followed a dependable rule. The longer they took to brighten and dim, the more luminous they truly were. That relationship turned a blinking star into a measuring tool. Brightness alone could not reveal distance. A star might appear faint because it was nearby and naturally dim, or because it was fiercely bright and far away. Leavitt's work gave astronomers a way to tell the difference. Hubble compared his observations across multiple photographic plates, including earlier exposures made with assistance from Milton Humason. The cycle settled into a period of just over 31 days. That number was not only a description of the star's behavior, it revealed how bright the star actually was. Now the plate carried a contradiction. The star was intrinsically luminous, yet it appeared exceedingly faint. To satisfy both facts at once, there was only one explanation. Distance. A great deal of it. Hubble calculated that Andromeda lay roughly 930,000 light-years away. Modern measurements, refined through a better understanding of different Cepheid populations, place the true distance at about 2.5 million light-years. But the modern number is not what changed astronomy. The original calculation had already crossed the critical boundary. Even against the largest estimates of the Milky Way available at the time, Andromeda sat far beyond its accepted edge. The familiar map no longer closed around everything. It opened. This did not come from philosophy or speculation. It came from a blinking star whose rhythm matched a mathematical relationship established years earlier on another set of photographic plates. To keep the single galaxy model, astronomers now had to reject the measurement that produced the distance. Hubble sent his calculations to Harlow Shapley, one of the strongest defenders of the existing view. The letter reached Harvard in February of 1924. According to later accounts, preserved through Harvard Observatory correspondence and Cecilia Payne-Gaposchkin's recollections, Shapley looked at the calculations and remarked, "Here is the letter that has destroyed my universe." The sentence was not about physical destruction. Earth had not moved. The Milky Way had not changed. Only the map had. For someone who had spent years constructing that map, the effect was still severe. A lifetime of careful work now belonged to a smaller universe than the one revealed by the numbers in his hands. Acceptance did not spread in a single evening. Scientific consensus rarely does. Questions continued. Measurements were examined. Independent scrutiny followed. On the first day of 1925, Hubble's findings were presented publicly at the meeting of the American Astronomical Society in Washington, D.C., read on his behalf by Henry Norris Russell. After that, the debate could not return to its old shape. Spiral nebulae no longer had to fit inside the Milky Way. They could be galaxies in their own right. Once that boundary fell, others followed. If Andromeda was another galaxy, then the night sky did not contain scattered clouds within one immense stellar system. It contained separate island universes extending far beyond the old map. The blinking star had measured more than distance. It had measured the limits of certainty. Today, photographic plate H335H still exists. The crossed-out N remains beside the handwritten VAR, exactly where Edwin Hubble corrected his own observation. The glass has not changed since 1923. Our map of the universe has